Okay, so I discovered what you guys were trying to tell me, especially you, Michael. I thought you guys were talking about this other video where I thought I was not recording and I was recording, but you were saying I thought I was the other way. So this is missing. Here we go. And let me get some of the stuff out of the way. And here we go. So this is the continuation. So we're going to name this one. This is the shape. This is that U shape that's called a parabola that we may have seen. I'm going to add a text box. And what I'm using again, this is Kami. So it's an extension. You can go to your app store and look for the Kami, K-A-M-I. There's the words. And this helps you to write on it. I'm going to use a text box in here and write this quad. Where is it? Let me move up. Well, once you start, I'm going to start over. This is the quadratic function, which is, and I can name it two different ways. F of x equals, now I'm going to x squared, but I can't do the squared on this, or can I? Oh, I can. It gives me some superscript, so I can put x, and I think I have to highlight the 2 and then go up here and then I'll lift it like an exponent. So x squared. So this is the name of this shape. When you see this shape, it's part of the quadratic family. And anything that you see where the x is squared, it's also part of the quadratic family, and you'll see that U shape. Now to figure out the domain and range, so for the domain, I'm going to look left to right. So I'm going to say how far to the left, and when you see the line go to the edge, you're imagining that it keeps going, and sometimes they'll put little arrows. But if you see the line to the edge of the graph, it goes beyond that. So when I look to the left, it's going forever, forever, because this line keeps going on and on and on. And that's my floating cursor with epilepsy. There we go. And how far the right? So on the right, it's going to the right, and it's going to continue. So it goes forever to the left and forever to the right. And what that means here is that the domain is all real numbers. And that's one of the abbreviations, NOS. And again, there's this other way to describe all real numbers, and they use this symbol. So I do 2 lines, and then I'm going to write the letter R, but I'm going to make it a little bit fancier than usual. So this is just the letter R. Then this means all real numbers. So you might see this, or you might see the words all real numbers, because it goes, anytime you see it go forever to forever. I'm waiting on my cursor. So it goes to the left forever and to the right forever. Now to do the range, I'm going to look down to up. How far down does it go? Well, it doesn't go down forever. So since it doesn't say down forever, I'm going to change the question to where does it start? So I'm going to look along the y-axis, which is where the range, where I count the range. And I'm going to start down, and when I get here, that's where it starts. So it starts here, and that is 0. And then it goes forever. So the way I'm going to write this one, and it's easier, I think, if I draw it. This range is about the y's, and it's starting at the 0. And then they're getting bigger from the 0. Are they getting bigger or smaller? Greater or less? So from here, they're going greater, they're going up. And then I want to say, is the 0 included? And right here at 0, if you either see a dot or a solid line, you're going to put that little line there, because the 0 is included. So to use either this one or this one with the line underneath, you need to either see a solid dot there or a solid line. And that's the case where you put the line underneath there when you're looking at a graph. Now, this particular one, it starts right here. So there's a point here, and then it goes forever in this direction. Now, if you're real careful, you'll see the shape is the same as this shape. It's the top, it's this part, but it just twisted around to the side. So it's really half of a parabola. Now, this particular one is called the square so I'm going to type it, square root function. And this one, and I can either say y equals or f of x equals. I'm going to say y equals the square root of x. So when you see x inside of this symbol, the graph should be this kind of crooked finger. This is the one where's the camera? There. I call it crooked fingers. So it starts and then it goes forever in one direction. So we want to look carefully at the domain of this one, because when I look to say how far to the left and how far to the right, when I go to the left, it doesn't go forever. So instead of saying forever, I'm going to say, where does it start? So it's domain, so I'm looking along the x-axis. Hopefully you're following this little plus sign. Bingo, that's where it starts. So domain is a story about the x's, and they're starting at 0. And they don't have a stopping point. So then it goes forever in one direction. So it's going from here, the x's, are they getting greater or less? And I see the graph over here, they're going greater. The numbers along the x line here get bigger. So this is greater. And then I want to look at the 0. Is the 0 included? And yes, the 0 is included. So I include that one. Now they might write this one out in words. All real numbers greater than or equal to 0. Now for the range, I'm going to look from the bottom to the top, down to up. So when I go down, where does it start? It starts at the 0. Range is a story about the y's. They're starting at 0. And from the 0, are they getting greater or less? Is it going up or is it going down? Well, this one's going up, so it's greater than 0. And the question, is 0 included? Oh, sorry. Sorry, Miss P. I'll talk to you later. Greater than or equal to 0. Next one. This one is kind of parabola, but it twisted. It wiggles. This one is called the cubic shuffle, or just a cubic. I like down, down, down. I know, I'm weird. How does this one go? We're going to say f of x equals, and this is x to the 3rd power. Where did that go? X to the 3rd power. So to get that exponent, I'm going to highlight the 3 and make it like the exponent. So x, or we say x cubed. And this one, if you want to add, we've got, it goes down forever and up forever. But the first thing I'm going to look at here is the domain. You know, how far to the left and how far to the right. So if I look to the left, it's going very slowly, but ever so slightly, it keeps going further and further to the left, to the left, to the left. It's going pretty slowly, but it's going to go to the left forever, and it's going to open to the right forever. So this one is all real numbers. You can write the fancy R, or you can write the words all real numbers. The range, how far down? Ooh, forever. How far up? Forever, forever, forever. All real numbers. So that's the cubic. This one starts out really low and then it speeds up. This is one we're becoming very familiar with in this day and age, which is this is our coronavirus model. The model it's following, at least at the beginning of the stages. The reason we're all doing this is because this is growing at such a rapid rate. Now, what I'm drawing in here is this invisible line that shows up. And in chapter 3, we're going to talk more about this particular function and this line. But there's an invisible line here. So this graph, if I'm coming from this direction, it's getting closer and closer. Oh, I don't want that. It's getting closer and closer and closer. I'm going to follow it. It's getting closer to that pink line that I wrote. Closer, 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 closer. And right here where it looks like it's touching, it's not touching. It's getting closer and closer and closer and closer, but it never is touching that. And this is, I see a little picture of me in the corner, and I don't know if you see the little me corner in your video, but it's like it's a little brother. You know, you have that. If you ever had an annoying little brother that gets right in your face, and he goes, "I'm not touching you. I'm not touching you. I'm not touching you," but he's like right in your face. That's what this graph is doing. It's getting right in there. The annoying little brother. I'm not touching you. So this will come in handy when we talk about domain and range. Now, I haven't given this a name, and this is exponential. And things that grow exponentially, there's things that grow exponentially in a good way. Starbucks was a business that grew exponentially. There was one Starbucks, then there was two, then there was 4, and then there was 8, 16, 32, and then it was they were just doubling and they were growing exponentially. So that's where it was good for the people that own Starbucks. What's bad is that you have one person sick, then you get 2 people sick, then that doubles, and then that doubles. And then, you know, you've got 500 people sick, and the next day you have 1,000 people sick, and the next day you have 2,000 people sick. And that's why the model, you know, this is such a significant situation, is that once things start doubling, the numbers can get really high, really fast. I mean, at the beginning, it seems kind of slow, and then zoop. So we'll talk about more of that later. Now, the way this one is written, I hope you're not watching the video because my tongue is sticking out as I try to write this. 2 to the power of x. I could have typed that in, but I wrote it in. Now, this is for doubling. Things that double use a 2. It really could be another number, because sometimes things will triple, or maybe they don't grow. They grow at a number in between, like 1.2. They're going just a little bit. That would be 20%. This is growing at 100%. But let's figure out the domain. Now, the domain means we're going to look to the left and look to the right. So I'm focusing on this line here, and how far to the left does it go? Yep, forever. How far to the right? Forever. So the domain, this is another example of one that is all real numbers. And that looks pretty messy, doesn't it? That doesn't even look like itself. All real numbers. Now the range, something different will happen here. So I'm going to look from down to up. And as I look down, it's like, well, how does it go down forever? No, because this line that I wrote here is like an invisible wall and it blocks it. So it's never going to get past here. It's only going to come down to that line and never touch it. And so it starts right here at that broken line. So if you see what this function, you're going to look for the broken line, and that's at 0. Let me do this right in here. This is still a story about the y's, and this is about the 0. Now from the 0, is it getting bigger or less? Greater than or less than? Well, from the 0, it's showing up. And so this is greater than. And then we always ask the question, is 0 included? Well, right here at 0, I see a dotted line. So if you ever see an open circle, you don't really see that very open, do you? Well, you see a little white sign. If you see the open circle, or if you see a dotted line, and that's what I see right here, if the 0 is a dotted line, then you use the symbols that don't have the line underneath. And so this one does not have the line underneath. And then we're going to take in chapter 3 and take at least 2 weeks to just talk about that function and how that works. But for now, you're looking at the name, the shape, zoop, and the equation, and getting familiar with how to do the domain and range. But this is the key part right now, is to connect these 3 things. We've got one last one. Now this it's kind of like windshield wipers, but they're going in opposite directions. This one has 2 names. I've seen it both ways. I've seen it called the rational function. I've seen it called the reciprocal function. And let me spell it correctly. And for this one, what's happening is that our function rule is that what we have is a fraction, which are rational numbers. They're called rational numbers. But also this is a when you flip the number, it's a reciprocal. Now what this has here, and maybe I'll put it in a different color, is it also has these invisible lines. So there's invisible line going horizontally, and the invisible line going vertically. And they represent places where the number is not. So if I look how far to the left, and I'm focusing, here's the function part right here, and it goes left forever. And how far to the right? Well, it goes forever. So it is all real numbers, but there's something happening here. And that's right here. And along this x-axis, right here, the graph never touches this line. It's got down here getting closer and closer, but it never actually equals 0. So it can be any number except 0. Now what all those symbols mean, and mathematicians it's just this language that we write things with symbols instead of words. This is all, real numbers except 0. And that's what all of that means. All real numbers except for 0. Range, how far down? Well, it's going down forever. How far up? Up forever. So this one also, I'm going to make this one real colorful here. Drawing. Well, so it's going forever, forever. It's all real numbers, but just like with the y, the x's, the y cannot be 0. It's everything except 0. Because when I go down, okay, there's the graph, there's the graph, there's a graph, and there's a graph. Oops, nothing here. Because this part of it is going up and up and up and is about to touch that, but it never actually gets to the 0. And then it picks back up just on the other side. So it can be any number except 0. So again, my apologies that this did not get out, was not in the beginning. I didn't understand which one you were talking about. And